Hi, in this video series, I'm going to talk about Chanakya's mind games, a fortnightly math puzzle published in Sunday Observer from 2002 June to 2005 July. So here's a paper cutting of the first math puzzle. This actually happened because at the time, 2002, there were some mathematically inclined serious students studying in the second year, but I was not teaching in the first 2 years at the time. But these students came to me because they wanted to do something in mathematics outside their courses. So they were directed to me by Professor Singh. So he was teaching, he taught them in the first 2 years, must be in first year. And so these students had gone to Professor Singh about their intentions. And he had actually asked them to come and meet me. I think that is because Professor Singh published a problem of the month when I was in the fourth year. That was in 1986. That was on the notice board of the math department. So I was one of the enthusiastic participants in that problem of the month. And then when I returned from the USA, I did the same. I published problem of the month on the notice board for a short time period. So that must have been the reason why Professor Singh asked these serious mathematically inclined students to meet me. So this resulted in publishing this puzzle in the Sunday Observer. They did everything, and they some of them helped me to do the puzzle in terms of typesetting, right? I think one of them used Corel Draw, as I remember. So they did everything, and I did not even meet. I did not even go to the lake house. So everything was done by them. And then at the time, this was actually published in the feature section, and the feature editor was Mrs. Hana Ibrahim. So I actually put the my name for the puzzle was the problem of the fortnight, or some problem of fortnight. But the editor of the newspaper had given this name. I think it must be because my name happened to be Chanakya. So Mrs. Hana Ibrahim was skeptical of publishing something like this because I don't think that she or anyone in the editorial staff had any experience in publishing something like this. But anyway, this was successful because it attracted quite a number of responses. In some puzzles, it exceeded 1,000. And also, if you look at the age range, it ranged from students to some actually in their 70s. So I'll share the details. So this was actually started in 2002, way before YouTube started. Yes, YouTube started in 2005. So I kept some of the letters I got, the solutions, hoping that one day I would be able to write a book, but I haven't got the time for that yet. But here is the YouTube, so I thought revisiting these mind games, these puzzles in this YouTube medium, right? So here I'm talking about the Chanakya's mind games. I will share I said that I kept actually some of the solutions sent. Here, one of them, right? Can see that. Actually, two are available, right? There is another one. So let's go to the puzzle. So let me share the screen. So hope you can see my screen. And actually, for the first puzzle, right, I actually selected these puzzles called alphametic, right? Alphametic. Um, so here's one such alphametic, which this is actually the example I gave in the column. And the brief introduction was that a challenging mathematical problem is posed every 2 weeks on Sundays. These problems require only elementary mathematical knowledge, but sound mathematical thinking. So for the first puzzle, I selected an alphametic, and this is an example which is actually you can find in many places, right? So based on this, now here actually, what this problem is that this apparently even word-wise, this addition makes sense, right? 40 plus 10 plus 10 is 60, of course. But then these letters stand for digits, and it says that different letters stand for different numbers taken from. So actually, if you count the different letters here, there are 10 of them, and there are 10 digits, right? And then these different letters stand for different digits actually says that those who actually know about functions, right? It is a one-to-one function, right, from these 10 letters to the 10 digits, right? One-to-one and on, you can say that. But these different letters stand for different numbers means that this assignment is one-to-one, right? So yeah, I given the sketch of solution. Before I go over this solution, I will show you the puzzle I came up with, right? So this actually, I made it myself by hand. Now this is here, the addition has no meaning word-wise, like in the example, 40, 10, 10 plus, is 60. But here is very, very easy. But there are problems like this in the literature, right? For example, send more money. Send more money. So this is so this is actually a famous puzzle published by I can't. I think someone called Dudney. You can check these in the internet. So here also, I think there are 10 letters, and there's a unique solution, right? So this also actually, the one I created actually is also in this form, right? There's a phrase, but the word-wise addition doesn't make sense, right? But I, of course, later in the series, I created alphametics with some meaning to the addition word-wise. For example, hold on a minute, I can find one. Okay, we'll share that later in the series. So I came up with something like red, blue, green. Sorry, that has to be, so I write it like this. Plus is piece, P-E-A-C-E, right? So here the addition actually, for me, the meaning was that these three colors actually represented the party colors, red, blue, green, right? So if they get together, right, there'll be peace. So So word-wise, I gave this meaning, and also I had this puzzle, Sri Lanka, minus peace. Let's see, P-I-E-C-E. Yes, P-I-E-C-E. So that is actually, I think, yeah, P-A-C-E, no peace, right? Again, in the political background that prevailed at the time, so this here, the subtraction actually means that uh, if you actually break the country, if you take away a piece from Sri Lanka, then there'll be no peace, right? So even word-wise, a meaning was given, right? All right. So maybe I should actually go over the solution of the example. Um, so the 40 plus 10 plus 10 is 60. So how do we do it? Let me write it here again. So 40, 10, maybe I will not solve it completely. We'll see. If it takes time, I will not do it. 60. So there are 5 letters. Yeah, 60. So addition, right? So here, the letters stand for digits, as I told you, in a one-to-one fashion, right? So how do we do the addition? We actually do the addition column-wise, right? And then if there's a carryover, right? So let's say that carryover is A, simple A, and then carry from tens columns to the hundredth column is B, and from hundredth columns to the thousands column is C, and from thousands columns to the what is it? 1, 10, 100, 1,000, 10,000 column, let's say D, right? So those are the carryovers, right? And then in the first column, right, the ones column, right? So Y plus 2n is equal to 10a plus y. So if you simplify this, you get 2n is equal to 10a. So from this, we can say that it is equal to 0 or 5, right? And is equal to 0 or 1, right? All right. So then if you look at the tens column, right, it is t, so let's label this as 1, this equation. And then we have the tens column, t plus 2e is equal to, so the 10b plus y, sorry, t, right? It's t. So if you simplify this, you get, wait a minute, I forgot, we need to add a here, right? Plus a. So then when you simplify, you get 2e plus a is equal to 10b, right? Now from this, you can say that simple a is even, right? Now, it's very simple observations, right? So I'm not going to explain it, right? So if a is even, then we know what the value of a is, right? It has to be 0, because 1 is not even, 0 is even number. So now it means that n is equal to 0, a is equal to 0, and then So 2e is equal to 10b, right? So then when we simplify this, because now we can substitute for a, the 2 is equal to 10b. Now, it can't be 0, right? Because n is 0. Remember, the assignment is 1 to 1, right? So that means e has to be equal to 5 and b has to be equal to 1, right? So, we have found now two of the digits that these letters stand for. So n is equal to 0, e is equal to 5, right? Now, when you do this, actually, you will actually have to, it may not be as smooth as I do because I have done this before and I'm sort of, going over it, right? So then what I do is that I look at the thousands column, right? If you look at thousands column, right? You have O, right? And the carryover from the hundreds column is C, right? Is equal to 10. Wait a minute now. It's yeah, O plus C is yes. So 10 D is a carryover from the thousands column, the 10,000 column, plus I. That's what we have, right? And then if you look at tens column, the 10,000 column, it is F plus D is equal to S, right? Now, here, since D is a carryover from the thousands column, and you can see that there actually you have only O and the carryover from this hundreds column. So D has to be 0 or 1, right? But D can't be 0. In that case, if it's equal to S, it can't be, if and it's different. So that means D is equal to 1, right? So if D is equal to 1, we have O plus C is equal to 10 plus I, right? So now from the thousands column, there has to be carry over to carry over this D, which is 1, right, to the 10,000s column. Now C actually is the carryover from the hundreds column, and you can see they actually have R plus T plus T. So that means C could be either 0, 1, or 2, right? But C can't be 0 because O plus C is 10 plus I. That means C is bigger than 0, but can C be is equal to 1? So in that case, O has to be 9. So 9 plus 1 is 10. So I is 0. No, I can't be 0 because 0 is taken, right? That means C is equal to, right? And O is equal to 9, right? And what is I? I is equal to 1. So we have found O, I, right? All right. Now we can actually look at the hundreds column. So that is actually R plus 2T, right? Plus B, which was 1. We found that B is 1, all right, is equal to 10 times C. And C is 10 plus C plus X, and we just found C. So that is, 2, and that is 20. So R plus 2D is equal to 19 plus X, right? Now you can see that how interesting, this puzzle can be. Even though it uses very elementary knowledge, the positional value system, right? And logic, right? You need to argue, right? So now let's see how the argument goes from here. Now already taken values. Let's see, these are the taken values. N is equal to 0 and I is equal to 1. And remember E was 5 and O is equal to 9. The 0, 1, 5, 9 are taken. So X has to be greater than or equal to 2, right? Because it can't take 0 and 1. So that means R plus 2T is greater than or equal to 21, right? See how you need to consider cases and then argue, right? So now R plus 2T to be bigger than 21, right? Let's see. If T is 5, it is actually 5 plus 2 is 10, and then R can be 8. 18. No, it won't work. If T is equal to 6, 6 plus 2 is 6 times 2 is 12. 12 plus 8, 20. No, right? So T has to be 7 at least. So if T is 7, then 2 times 7 is 14. 14 plus can be 8, 22, yes. So R can be 8, right? Or T can be 8. So 8 times 2 is 16. 16 plus 7 is 23. Okay, R is 7, right? And R, can R be equal to 6? So let's say 8 times 2 is 16 plus R is 6. 16 plus 6 is 22. Yes, even 6, right? It can be 9. All right. Now, let's look at, let's look at the 10,000 column. So it is, if plus 1 is equal to 6, right? So we got that if plus 1 is equal to 6, right? F plus 1 is equal to, S, right? And that means if and S are consecutive, right? But you can see that, so F can't be 6, so F and S, right? So F and S, right? If can't be 6 and S can't be 7, right? Look here, right? And F can't be 7 and S can't be 8. Same reason, right? Then only available consecutive numbers are 2, 3, even 4, 5 are not available, right? 6, 7 not available, 7, 8 not available. So F has to be 2 and S has to be 3. See how beautiful this can be, right? So these can't be, right? So it has to be this, right? F is equal to 2 and S is equal to 3. So now we have found, so that means we can now re-estimate, right? Re-estimate this, right? Now actually R plus 2T, right? So X actually has to be greater than or equal to 4, right? So that means, so this has to be greater than or equal to 4 plus 19, 23. So in that case, right, there are only two. So T has to be 8 and R has to be, that is 16 plus 7, 23. So these are the only options, the choice, right? Now one more is left, Y, and you can see that only unsigned number is 6, right? So basically, it is over. I will not actually do the finishing touches. I'm going to leave it to you, right? So as you can see, this puzzle, right? Right? It's a very, simple looking puzzle, right? But uses only the knowledge of addition, right, in our number system, place value system, and then but the argument actually in finding the solution is quite interesting, quite mathematical, and actually we can enjoy and we can learn mathematics. We can improve our mathematical thinking, right? So now, uh, for you actually to solve this on the puzzle given here, this is very, very easy. Now you can check if it is that easy, right? All right, then I'm going to wind this up, and I'll see you again in another episode of Chanakya's Mind Games. Till then, take care.